I'm Kyle Agum, and this is my solution for the P3 exam. So as you can see below, this is the example of the amplifier circuit. So the problem is find the emitter current, emitter voltage, base voltage, collector voltage, overall voltage gain, and assume that collector current is equal to emitter current, and also determine the output collector voltage. So as you can see below, there's the clue right there. The DC equivalent of the circuit is here, and the AC equivalent of the circuit is here. So let's start with the DC equivalent of the circuit. So first, we need to apply the Thevenin's theorem and the Kirchhoff's voltage law. So let's start with the Kirchhoff's voltage law. So RTH is equal to R1 is parallel to R2 over R1 plus R2. So it is equal to the R1 is equal to 47 kilo ohms, and RT is equal to 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms, and it is equal to RTH is equal to 8.25 kilo ohms. So let's proceed to Thevenin's theorem. So VTH is equal to VCC times R2 over R1 plus R2. So 10 volts times 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms is equal to 1.75 voltage. So let's proceed to collector current and emitter current. So VTH minus VBE over RE plus RTH over DC beta. So sum up, it is equal to 1.75 volts minus 0.7 volts over 940 ohms. So as you can see, it is equal to 940. So we add both RE1 and emitter current to resistant to 1 and 2. So it is equal to 940 ohms. So the value of collector current and emitter current is equal to 1.06 milliamps. So to get the base voltage, let's go first with the emitter voltage. To get the emitter voltage, emitter current times the sum of the emitter resistant 1 and emitter resistant 2. So 1.06 milliamps times 940 ohms is equal to 1 volts. So let's proceed to base voltage. So VE or emitter voltage plus 0.7 volts. So emitter voltage is equal to 1 volt. So 1 volt plus 0.7 volts. So base voltage is equal to 1.7 volts. And so let's proceed to collector volts. So it's equal to VCC minus collector current and collector resistance. So 10 volts minus 1.06 milliamps times 4.7 kilo ohms. So collector voltage is equal to 5.02 voltage. So let's proceed to AC equivalent circuit. So as you can see, this is the AC equivalent circuit. The solution for this AC equivalent circuit is equal to R sub B is equal to 26 millivolts. So this 26 millivolts is the standard formula. So 26 millivolts over emitter current. So 26 millivolts over 1.06 milliamperes. So R sub E is equal to 24.5 ohms. So let's determine the attenuation. So base input resistance is equal to AC beta times R sub E plus RE1 or emitter resistance 1. So it's equal to 175 times 24 times ohms plus 470 ohms. So base input resistance is equal to 86.5 kilo ohms. So let's proceed to the total input resistance. So the total input resistance is equal to R1 parallel to R2, and R2 is parallel to input base resistance. So this input base resistance, the value of input base resistance is equal to 86.5 kilo ohms. So we simplify the solution. The total input resistance is equal to 7.53 kilo ohms. So let's proceed to attenuation. So the formula for attenuation is Rs plus Rn total, or total input resistance over total input resistance. So 600 ohms plus 7.53 kilo ohms over 7.53 kilo ohms. So the value of attenuation is equal to 1.08. So we need to solve for RC. So this is the RC. RC is equal to RCL, RC times RL over RC plus RL. So 4.7 kilo ohms times 47 kilo ohms over 4.7 kilo ohms plus 47 kilo ohms. So the the value of RC is equal to 4.27 kilo ohms. So let's proceed to amplifier voltage gain. So to get the amplifier voltage gain, the formula is collector current over emitter current 1. So 4.27 kilo ohms over 470 kilo ohms is equal to 9.09. So that's the value of the amplifier voltage gain. And to get the overall voltage gain, we need to use this blue right there. So multiply the amplifier voltage gain by the reciprocal of the attenuation. So as you can see in the formula, overall voltage gain is equal to 1 over 1.08 times 9.09. So the overall voltage gain is equal to 8.45. So let's proceed to the collector voltage. So to get the collector voltage in AC form, so the value of the voltage is equal to 10 millivolts. So to get the voltage collector, or the collector voltage, the formula is the overall voltage gain times the Vs. So 8.45 times 10 millivolts. So the collector voltage, the value of the collector voltage is equal to 84.5 millivolts. So in calculating the output collector voltage, we need to determine first the peak values right there. So we need to calculate these peak values. So the VCP max and the VCP minimum. So the maximum collector voltage is equal to the collector voltage in DC plus the common value 1.414 times the VC, or the collector voltage in AC. So it's equal to 5.02 voltage plus 1.414 times 84.5 millivolts. So that's the collector voltage in AC. So the value of the maximum VCP is equal to 5.14 volts. So let's proceed to the minimum VCP. So in getting the minimum VCP, it's all the same, rather than you need to change the sign. So in case it is positive, change it to negative. So the collector voltage in DC minus 1.14, that's the common value, times collector voltage in AC. So the value of the minimum collector voltage is equal to 4.90 voltage. So let's proceed to the output voltage collector. So or the output collector voltage. So in getting the output collector voltage, need to multiply the common value or common value, the 1.414 times the VC AC collector voltage in AC. So as you can see, I disregard the collector voltage in DC because the coping capacitor in C3 keeps the DC level from getting to the output voltage. So the value of the AC is equal to 84.5 millivolts. So as we simplify this one, the output collector voltage is equal to 119 millivolts.